Hello and welcome. In this video session, we will see some examples of assignment operators and bitwise operators used in Python. In this program, we demonstrate the assignment operators. The assignment operators are used to assign a value to the operands. For example, here we have var2 equal to var1 plus var2. Here, this equal to is the assignment operator. In this case, we assign the calculated value to the left hand side variable, that is var2 equal to 10 plus 10 equal to 20. So we get var2 equal to 20. Let us execute this program and explain along with. We get var2 equal to 20. So we are assigning this right hand side value to the left hand side operand. So next we have plus equal to. In plus equal to, it works as follows. The new value of var2 will be calculated using var2 equal to var2 plus var1. So we can also say that this is equivalent to var2 equal to var2 plus var1. So this plus equal to, when it expanded, can be written like this: var2 equal to var2 plus var1. So in this case, we get var2 plus var1 equal to var value of var2 after plus equal to is, that is 30. That is, initially it was 20. 20 plus 10 equal to 30. Now var2 has a value 30. Now again var2 we have minus equal to operator. Here we get in the same way we get here. Let's expand this expression: var2 equal to var2 minus 5. So we got 25. That is, we had the value 30. 30 minus 5 is 25. So now the new value after the performing this is 25. Okay, now the value of var2 is 25. Now we perform divide by equal to operator. So this is nothing but 25 divided by 5. That is nothing but 5. So we get 5 here. Let us expand this as well. var2 equal to var2 divided by 5. Similarly, a double division symbol is used if we want only the floating point. So this can be expanded as follows: var2 equal to var2 by 4. So the value what we get here will be 1. So 5 divided by 4, that is the integer part we are looking for. 5 divided by 4 is nothing but the quotient part is 1. So we get var2 is 1. Now next, let's see the next operation. We have star equal to operator. So this is nothing but var2 equal to var2 into 10. So var2 value is 1 here. So 1 into 10, we get 10. So value of var2 after star equal to will be 10 here. So now these are the different assignment operators used in Python: equal to, plus equal to, minus equal to, divide by equal to, double divided equal to, star equal to. Now as a note, let us see the difference in assignment operator and relational operators. In relational operators, we use double equal to symbol. For example, in the previous example, we can see we used if a double equal to b, if a less than equal to b, if a greater than equal to b. So those were the relational operators. And whereas assignment operator, we use a single equal to, or we use this to assign the value, whereas relational operators are used to compare the values. And as a note, relational operators returns only ones or zeros. whereas assignment operators are used to assign the value to the operands. So if you see here, in all of the examples we are assigning the value to the operands, whereas in the previous as relational operators we were verifying some condition of the variables, and based on that we were taking some actions, like if a is greater than b, then take some action, else take some other action. So this is the difference between the relational operator and the assignment operator. Now in the next example, let's see the bitwise operator. So this is an example of bitwise operators used in Python. Let us compile this program and explain along with. So now we have var1 equal to 15 and var2 equal to bitwise ANDing with 3. So we get var1 after bitwise ANDing is 3. So now let's explain how we got 3 here. So we have 15. 15, the binary representation of 15 is as follows, and binary representation of 3 is here. So when we do bitwise ANDing, so only if both bits are 1, we get the corresponding bit as 1. So we got the first bit as 1. The second bit, both bit are 1, so we got the second bit also as 1. In this case, we have the third bit 1, and here the third bit is 0. So we get 0, and here also similarly we get 0, and anything bitwise ANDing with 0 and 0 is 0. So the final result is in binary 1 1, that is nothing but 3. Similarly, we perform bitwise ORing. In bitwise ORing, let's say we have var1 equal to 15, that is the binary representation is shown here, and we are ORing bitwise ORing with 1 0, that is nothing but 1 0, hexadecimal 1 0. Now the ORing wise, if there is even a single 1 present, the output will be the 1. So 1 or with 0 is 1. In the same way, 1 or with 0 is 1. And here 1 or with 0 is also 1. So we get this result. Please refer to bitwise ORing explanation if you want more details. So now we got var1 after bitwise is var2. So we got bitwise ORing value was 31. So this is nothing but this, the corresponding value is 31 in decimal. Next, let's see the bitwise XOR. In bitwise XOR, it works as follows. Now let's say var1 is 15, and we are XORing with hexadecimal 11. This is a value. So in case of XOR, if both bits are same, then we get 0. If both bits are different, then the resultant will be 1. So example, 1 XOR with 1 is 0, 1 XOR with 0 is 1, 1 XOR with 0 is 1. Similarly, 0 XOR with 1 is 1, and 0 XOR with 0 will be 0. So we get a decimal 30 in this case. So we got bitwise XOR is 30. Now let's see the negation part. Negation part is used to negate each of the bits. For example, let's take var1 equal to 1 and var2 equal to negation of var1. This is nothing but we have var1 here, and when we negate, each of the values will be negated. For example, 0 will become 1, all these 0 zeros will become 1s here, and all these 3 zeros will become 1s here, and this 1 will become 0 here. So this is nothing but minus 2. The binary representation of minus 2 is this one. So we get bitwise negation as minus 2. Then let's see the left shift bitwise operator and right shift bitwise operator. So in case of a left shift bitwise operator, we need to use double less than sign, and the explanation is as follows. Let's say we have var1 equal to 1, and we are supposed to left shift by one number. So in this case, var1 is 1, and when we left shift by 1, this comes in this left position, and this will be replaced by a new 0. So for example, this moves here. After one moving here, this will be its new position, and this position is filled with 0, and all the bits will be shifted by left by one position. So now the resultant will be 2. So this is 2 in memory. So we get after left shift by 1 is 2. So now let's see the right shift example. Now let's say we have var 1 equal to hexadecimal 1 1. So now the hexadecimal representation of 1 1 is as follows. Now let's say we have to right shift by 2 places. So this will be left shifted by 2 positions. That is, it is placed in this bit position. This one will be placed in this position, and this one, as a rollover, it goes, and a 0 will be present. So the right shift 2 times of 0x11 will be as follows. So this value is nothing but 4. So I think there is a correction required here. This is a 4 here. So so this represents representation in binary is nothing but 4. So the right shift shifts the value by by the given position right side, and the left shift shifts the given value by left position by the given number of times. And we have bitwise negation, and we have bitwise ORing, and we have bitwise ANDing.